Okay, in this video, we're going to solve this integral right here. And so let's begin. So I'm going to say x is equal to tan theta. And then I'm going to get dx is equal to secant squared theta d theta. With that, I'm going to swap. So 1 dx, instead of saying 1 dx, I'm going to say secant squared theta d theta. So secant squared theta d theta divided by, instead of saying x squared, I'm going to get tan squared theta. So I have parentheses 1 plus tan squared theta, close it, square it. Now it's important that we know some of our trig identities. 1 plus tan squared theta is the same as secant squared theta. So we're going to swap again. Secant squared theta d theta divided by parentheses secant squared theta, close it, squared. And so we're squaring this squared piece so we can rewrite it again. We're still going to keep our numerator, so secant squared theta d theta divided by, instead of saying secant squared theta squared, we'll just do secant raised to the 4th power theta. Now of course now we can simplify, so we're going to get 1 divided by secant squared theta d theta. And instead of saying 1 divided by secant squared theta, we could say cosine squared theta. So we have cosine squared theta d theta. From here we're going to use another trig identity. We know cosine 2 theta is equal to 2 cosine squared theta minus 1. Now we have cosine squared theta d theta, and so let's isolate that too. So I'm going to add 1 here, add 1 there. So I'm going to get cosine parentheses 2 theta plus 1 is equal to 2 cosine squared theta. And we want to get cosine squared theta by itself, so divide by 2, divide by 2. And so we get cosine squared theta is equal to cosine parentheses 2 theta plus 1 divided by 2. And so this is a good reference that we're going to need. And now let's replace. So this is 1/2. So we can say 1/2 the integral cosine parentheses 2 theta d theta. But let's split up the 1. So I can say plus another 1/2 the integral 1 d theta. Now I'm going to need more room, so we're going to continue with this line right here. Okay, now we're getting closer to kind of the idea on how we're going to solve this problem. Now we're going to use u substitution. So I'm going to say u is equal to 2 theta, so du is equal to 2 d theta. And so let's rewrite again. So I have 1/2 the integral, we'll say cosine parentheses u, close it. Instead of saying d theta, I want in terms of du, so let's divide by 2, divide by 2. So then I could say du divided by 2. This piece remains the same, so plus 1/2 the integral of d theta. And so let's rewrite. So we have 1/2 times a half, so we get 1/4 the integral cosine parentheses u du plus 1/2 the integral d theta. So the integral of cosine u will give you sine u, so we have 1/4 sine parentheses u. And in this case, for this piece, the integral of 1 will give us our theta, so plus 1/2 theta, and then add your plus c. And earlier we said u is equal to 2 theta, so let's replace that. So we have 1/4 sine parentheses 2 theta plus 1/2 theta plus c. Now we need to go back to figure out what is theta. Earlier we said x is equal to tan theta, so we're going to need to apply that. So we said x is equal to tan theta. Therefore theta is equal to tan inverse parentheses x. But still, focusing on this piece here, x is equal to tan theta. If I was to draw a right triangle, this is my right angle, this is my theta. If x is equal to tan theta, opposite would be x, adjacent would be 1, and the hypotenuse would be x squared plus 1 squared, so x squared plus 1. Theta is important because of this piece, but this piece, we're going to need this. I'll show you why. Alright, so let's continue. Instead of saying sine 2 theta, we can use another trig identity. Sine 2 theta is the same as 2 sine theta cosine theta. So let's rewrite it. We have 1/4 sine parentheses theta cosine parentheses theta. Next, we're going to use another trig identity. Sine 2 theta is the same as 2 sine theta cosine theta. So let's rewrite that. 1/4 parentheses 2 sine theta cosine theta, close it, plus 1/2 theta plus c. Alright, so let's continue on. 1/4 times 2 will give you 1/2. So we have 1/2 sine theta cosine theta plus 1/2 theta plus c. Now we finally have everything, so now we can kind of just replace. So we have our 1/2 sine theta. Sine is opposite over hypotenuse. So opposite is x, divided by hypotenuse is this piece, so square root x squared plus 1. Close it. Cosine theta is adjacent over hypotenuse. So 1 divided by the square root of x squared plus 1. Close it. Plus 1/2 theta. Theta is this thing. Theta is arctan x. So 1/2 tan inverse x plus c. Then we can clean up a little bit, so one more step. So now I'm going to multiply the numerators. 1 times x times 1 is just x, divided by the square root of x squared plus 1 times the square root of x squared plus 1. The square roots cancel, but we still have our 2, so 2 parentheses x squared plus 1, close it, plus tan inverse parentheses x divided by 2 plus c. This right here is our final answer.